Have you ever wished you could travel through time, see dinosaurs, or maybe even glimpse the distant future? Time travel isn't just a fantasy, it's a question that fascinates both scientists and storytellers alike, sparking endless curiosity. In this video, we'll explore what science really says about time travel, separating fact from fiction and myth. We'll dive into Einstein's groundbreaking theories, Hollywood's wildest ideas, and the real mind-bending challenges of actually moving through time. So, let's begin our own adventure. No DeLorean required, just a sense of curiosity and a vivid imagination. Movies have given us countless ways to imagine time travel, each film offering a unique vision of how we might move through the past, present, or future. From the earliest days of cinema, storytellers have been fascinated by the idea of bending time, using it as a tool to explore our deepest hopes, fears, and questions about destiny. Whether it's a whimsical adventure or a mind-bending thriller, time travel stories let us ask, what if we could change our fate, or witness history firsthand? In Back to the Future, the rules are clear. Changing the past can have dramatic consequences, even risking erasure from existence itself. The film paints time as a single, fragile thread. One wrong move, and everything unravels. This idea of a delicate timeline where every action has a ripple effect has become iconic in pop culture, shaping how generations think about cause and effect. But not all movies agree. Avengers: Endgame takes a different approach, introducing the concept of alternate timelines. Here, changing the past doesn't rewrite your own history. Instead, it creates entirely new realities, each with its own possibilities and consequences. This multiverse idea opens up endless narrative doors, letting characters explore worlds where anything can happen. Then there are films like Groundhog Day and Edge of Tomorrow, which trap their characters in relentless time loops. Forced to relive the same day over and over, these protagonists must learn, adapt, and grow to break free. These stories use repetition to explore personal transformation, resilience, and the power of second chances. Christopher Nolan's Tenet flips the script entirely with its concept of inversion. Here, people and objects move backward through time, creating a world where cause and effect are turned upside down. This mind-bending take challenges our basic understanding of how time flows, making us question what's possible. These cinematic models aren't just entertaining, they echo real scientific debates about the nature of time. Physicists and philosophers alike grapple with questions about whether time is linear, cyclical, or something even stranger. Movies give us a playful way to explore these complex ideas, sparking curiosity and wonder. So, as we dive into these stories, let's ask ourselves, how close does Hollywood get to the truth? And what can these films teach us about the mysteries of time itself? Imagine if you could step into a machine and travel into the future. It sounds like pure science fiction, but science says traveling to the future is actually possible, at least in a very real, measurable way. This mind-bending idea isn't just fantasy, it's already happening thanks to Albert Einstein's revolutionary theory of relativity. Over a century ago, Einstein showed us that time isn't fixed. Instead, it can stretch and shrink depending on how fast you're moving or how close you are to a massive object. According to relativity, time moves slower for objects traveling at incredible speeds or near intense gravitational fields, a phenomenon called time dilation. This means that two clocks, moving differently or experiencing different gravity, will tick at different rates. For example, astronauts living and working on the International Space Station are actually time travelers. Because they're moving so fast above Earth, they age just a tiny bit slower than people on the ground. It's only a fraction of a second, but it's real, and it's been measured with atomic clocks. Hollywood has even explored this concept. In the movie Interstellar, astronauts near a supermassive black hole experience just a few hours while years pass back on Earth. While the movie takes it to the extreme, the science behind it is accurate. The stronger the gravity, the slower time moves. If we could build a spaceship that travels close to the speed of light, time for those on board would slow down dramatically. A year on the ship could mean decades or even centuries pass on Earth. In theory, you could leap into the far future just by taking a very fast journey. The real challenge isn't the physics. Einstein's equations work. The hard part is building the technology, creating engines powerful enough, protecting travelers from cosmic radiation, and solving countless engineering puzzles. So, traveling forward in time isn't just a dream. It's a scientific reality, limited only by our imagination and our ability to build the machines to get us there. The future is out there waiting for us to catch up. Traveling to the past is where things get tricky. Paradoxes abound. The classic grandfather paradox asks, what if you prevent your own birth by changing the past? Movies like Back to the Future thrive on these dilemmas, but physics isn't so forgiving. The Novikov self-consistency principle suggests the universe would prevent paradoxes. History can't be changed. Alternatively, the many worlds theory says changing the past creates a new timeline, not a contradiction. Both ideas are unproven, and for now, time travel to the past remains a theoretical puzzle. The past, it seems, is well protected. Could shortcuts through space-time, wormholes, make time travel possible? This question has fascinated scientists and science fiction fans alike for decades. The idea of stepping into a tunnel and emerging light years away, or even in a different era, is both thrilling and mind-bending. But what exactly are wormholes? And could they ever exist outside the pages of a novel or the frames of a movie? A wormhole is a theoretical tunnel connecting distant points in space and time, predicted by Einstein's equations of general relativity. In theory, if you could travel through a wormhole, you might cross vast cosmic distances in an instant, or even move backward or forward in time. However, keeping a wormhole open would require exotic matter with negative energy, something we've never observed in nature, or created in a lab. Without this mysterious substance, any wormhole would collapse before anything could pass through. Movies like Contact and Interstellar use wormholes for dramatic effect, showing characters leaping across the universe in seconds. These cinematic wormholes are visually stunning and capture our imagination, but the reality is far less stable and much more complicated. In real physics, the forces involved would likely destroy anything trying to travel through. Another wild idea from theoretical physics is the concept of cosmic strings, hypothetical defects in space-time that might have formed in the early universe. Some scientists have speculated that if two cosmic strings passed close by each other, they could warp space-time enough to create loops, potentially allowing time travel. But so far, cosmic strings remain purely theoretical, with no experimental evidence to support their existence. Both wormholes and cosmic strings face enormous scientific and engineering hurdles. The mathematics is daunting, and the technology required to manipulate space-time on such a scale is far beyond anything humanity has ever built. Even if we could find or create exotic matter, we'd need to solve countless other problems to make time travel a reality. We haven't found exotic matter or cosmic strings, and building a time machine with them is far beyond our reach. Every experiment so far has come up empty, and the laws of physics as we know them seem to stand firmly in the way. For now, these ideas remain in the realm of speculation and imagination. They inspire new theories and fuel our curiosity, but they also remind us how much we still have to learn about the universe. The universe keeps its secrets well, and perhaps one day, we'll discover if shortcuts through space-time are truly possible, or if they'll remain forever in the domain of wild ideas. Quantum mechanics adds even more mystery to time. Quantum entanglement links particles instantly, but it can't be used to send messages, or people, back in time. Some quantum theories allow for particles to briefly move backward in time, but only at the tiniest scales. Movies like Ant-Man play with these ideas, but real quantum effects don't allow for human time travel. The quantum world is strange, but it doesn't offer a practical time machine. Still, it challenges our understanding of reality and time itself. The frontier of quantum physics may hold surprises, but for now, time travel remains science fiction. Our exploration of time travel reveals a universe stranger than fiction. Science proves we can travel to the future, if we solve the engineering challenges. The past, however, is locked behind paradoxes and unbreakable rules. Wormholes and quantum tricks remain tantalizing but unproven. Movies inspire us to dream, while physics keeps us grounded. The quest to understand time pushes science and imagination forward. We may not visit the dinosaurs soon, but the journey to understand time is just beginning. Who knows what discoveries the future holds?